Hi guys. Our final topic is sessions. We've one more topic when this is concluded to look at the assignment, but this particular topic here brings to a conclusion our work on JavaScript web application development for the moment. An awful lot more to learn, which we'll be resuming in January in full stack development, but we've had a good start here now and you've plenty to think about and sufficient tools, I think, to have a go at the assignment we've set for the module. As I said, we will do one more topic to look at the assignment and a few more stretch goals, which will go beyond what we've covered so far. But everything we've covered in the last sessions now, up till including today's, should be enough to do most of what you need to do for that project. So today we're going to introduce sessions that'll be familiar to you from our work in Web Development 1 in Play. And we look at using sessions in JavaScript. Sessions UX, which is going to look at how we design our sign up and login forms. And finally, creating and managing sessions. Very similar really to what you would have learned in the Play framework. So there's nothing conceptually very new here. We're just using, of course, a different framework, different tools, but remarkably similar, you may find. In the labs, we have 3 labs this time. One just to get up and running with playlist 4, just bringing in sessions to the project as we left it last week. And then 2 additional labs. You can skip these for the moment, or you can resume them a little bit later, perhaps in the context of your assignment. Some new features that we're going to add on. Don't really cover them in the lectures, but they're fairly transparent. Update an existing song, or track rather, I should call it. And find the shortest song or track. Sorry, I'm using song and track interchangeably there. How these are structured, how these features are implemented may be important depending on how you go with the assignment. Okay, that's it then. One more topic to go as I mentioned, and talk to you then. Sessions. You've seen the notion of sessions before. We've implemented sessions in our Play applications. And we're following very similar patterns in JavaScript now to what we covered in that course. You will recall the notion of pages being independent of each other and a user navigating from page to page as part of the web since its inception. And in fact, the original web didn't really have a notion of sessions as such. It's something that's been layered on at later stages. Effectively, what sessions allow us to do is to track a user. That is, to get some understanding of who is operating the browser and possibly present to that user information customized to their interests and maybe present information that they may have themselves composed. This is all implemented via session tracking, and the essential idea is somehow when users make requests to the browser, we're able to track the user, perhaps using some kind of ID. And then for all subsequent requests from the same browser, we're able to recover the ID of the user and then customize the user experience. This is implemented on top of the web, as we mentioned, because the original web in its conception was stateless. That is, requests were all considered independent of each other. Each request had no notion of a previous request or subsequent requests. Requests, remember, are simply pressing a link on a page as we move around within a site. So sessions allow us to group those requests into some overall context so that we're able to present more meaningful information because somehow we have a deeper understanding of who is operating the browser. Perhaps the user has logged in, for instance. So this is called session tracking. A lot of it is built around the idea of session ID, which is somehow managed in collaboration between the browser and the application. And that ID is exchanged between the browser and the app on all requests from perhaps a given user. Now, there are many ways of doing this, and it's still an evolving field with different approaches emerging over the years. Some of the ones we've seen to date in the technology have been cookies. You've seen this in action. Hidden form fields, URL rewriting, and JSON web tokens. Now, cookies are the perhaps original in that they're the easiest one to get your head around, and they're the ones we've already implemented in play. Here we've got the browser and the application collaborating. The application instructs the browser to set a cookie, that is to store inside the browser's persistent store an ID or some information pertaining to the specific user. And then as long as that user is operating the browser and is on the same site, that cookie will be exchanged or sent over to the server each time. The server application can inspect that cookie, and typically we use that cookie to look up who this user is. We may be doing this on each request, remember. So the technique, and this is the one we'll use, will be to somehow persuade the browser to set this cookie, and then to have that cookie sent over on all subsequent requests. We'll take responsibility then in the server for recovering that cookie, that ID, and using it to look up whatever store we have on the server side to see who this user is, so we can present the appropriate information to them. This is reasonably straightforward to implement because we don't need to get involved in the low-level details. The browsers understand cookies, and we're merely ensuring that they, via the framework we're using, are managing those cookies for us. It is possible to inspect the cookies that is inside the browser using the developer tools, inspectors of one kind or another. We can look into the cookie store and we can see details of the cookie as it is currently saved in the browser's memory. This may be encrypted, so what we see may make too much sense, but we can't see metadata around it. So cookies is one technique, URL rewrites are another. In this instance, when requests are made, we would be changing the actual request parameters themselves, such that an ID could be included in the request. So for instance, if I'm making a request to a server my home, then request parameters visible here mean that after a question mark, we can provide any information we like. In this case, I'm providing a string, session ID equals 123. And the server can pick up that information and regard 123 as the ID we're now going to be using to look up the user, for instance. We'd have to program this, so this is not going to be available automatically to us. We would have to do a bit of work rewiring our routes, for instance, with dynamic routes, something we've started to do already. Hidden form fields, another perhaps superannuated technique. In this instance, we provide in each of our forms, when we're submitting data, an extra hidden input field. So you'll notice here there's the hidden keyword. It's a type hidden. This means it's not going to interfere in the user experience. It's not going to be presented on the form the user sees, but we are providing information which will be exchanged or sent to the server, and that can be the session ID itself. Again, the implementation of this would be a bit of work. We'd have to make sure our templates were being generated with these extra fields at all stages, and we would be managing those IDs ourselves somehow to make them meaningful to the application. So if we had a form like this, for instance, I'm filling out a form to make a donation of some kind, then I might be inserting straight into the form this hidden form field highlighted. It's not visible on the form itself, but you can see we've got some notion here that there's an ID being generated, and that ID is going to be significant to our application. Other techniques we haven't discussed before, JSON web tokens. These are becoming much more prevalent in recent years. And there's a variety of techniques associated with tokens, but they all revolve around the idea that when you log in, you get a heavily encrypted string, which is your token. And you can use that token then on all subsequent interactions. So it's quite like a cookie in how it's conceived, but there's more strength in cryptography, and the tokens don't necessarily have to be stored in the cookie store. They're maybe stored in other regions. This is often used where the client is not a browser. So for instance, if you're on a mobile phone and you're logging into some service, Twitter or Facebook or whatever, then you may be using tokens to log in from that client application, non-browser, and that those tokens then are managed by the application and stored for a certain period of time. In general, web frameworks that we're going to use, cookies would be preferred. They are reasonably simple to implement from the point of view of the programmer. The techniques we're looking at in JavaScript in this session are very close to what we covered in Java. Effectively, we'll be hijacking the requests and ensuring that there's an extra piece of information always available in each request. And that extra information will be usually associated with the ID of the user who's just logged in. How would we work sessions into our application? Currently, our application lists out playlists, and it lists out all the playlists entered. There's no user login. There's, if you like, a global list of playlists maintained in the store. That is, if we were to look into the playlist JSON file, we'll see this playlists array here. And we'll see that each playlist is just these two things. It's got a title and it's got an ID. That's a unique ID for the playlist itself. So how would we associate playlists with a logged in user? Well, it's reasonably straightforward. We introduce another attribute into the playlist. We'll call this user ID. This is going to be an ID associated with the user who created the playlist. This, I guess, will be the user who has logged in, or who was logged in when the playlist was created. So we're going to need a new method, get playlist by user ID. This will be a method we will use in the playlist store. You supply the ID of a user, and the method will recover the playlists that match this user ID. So we get back more than one playlist. Once we've got that method in place, it's reasonably straightforward to get it running. Somehow we've got to figure out who is logged in. We figure that out by a new method called getLoggedInUser. We'll discuss that shortly. Once we've got that ID of the logged in user, then we're passing that ID to the playlist getPlaylistUserID. We're passing it in here. And this means we're going to get back the playlists for the user concerned. Similarly, for let's say adding a playlist, the first thing we will do is we will figure out who is a logged in user, and then we will use the ID of the logged in user as the user ID in the playlist object we are creating. You can see that in action here. Previously our playlist just had a title. Now it has also the ID of the logged in user. So that's basically it. It's very simple. What we have to do now is figure out how do we know who is currently logged in. The session's user experience. It's going to require us to change the way the application launches. We'll have login and sign up as the landing page. There'll be buttons on that page. If we press login, we're presented with a login screen, and sign up gives us the sign up screen. These will be new views incorporated into our app. The implementation of these, well, first of all, starting with the landing page, Our new index will have a welcome menu. This is new. And the welcome menu will just have login and sign up as we're showing here. Pressing those buttons should hopefully take us to the other views, and the sign up form will be a classic Bulma form. I think we've seen this kind of thing before now. Effectively, if you are building up a form, the form structure is using the various classes and attributes of the Bulma library. This allows us to style the form fairly effectively and making sure we've got the appropriate input fields. First name, last name, email, password, they're all named accordingly, and they'll resurface in the controller that will be handling the submission of this form. Login is much the same, just simpler, just username and password. So the routes we will need then are a landing page or root page or start page for the app / we'll go to accounts controller index. That's a new controller we're introducing. And then login and sign up will be accounts controller login and sign up methods respectively. So these are new routes we're incorporating into the application. So what happens in these controller methods? Index method, simple enough, just display the index view, and the other two are similar, login and sign up. These are not, remember, implementing the login feature yet, they're just displaying the pages, display the login view, display the sign up view. We're not handling the submission of the form data, the sign up data or login data in these methods. These methods, login and sign up, are just displaying the views. Our next step will be to implement the submission of login and sign up forms and lead the application login and sign up flow procedure, so we're showing the appropriate playlists for the logged in user. The routes for register and authenticate, well, these are the ones you've got to implement now. Register will be submitting a sign up form. Authenticate will be submitting a login form. And we'll see in the next section how these are implemented. Okay, we've got our forms together and we understand how a user ID, if we can come up with it, can be used to associate playlists with individual users. It's now time to get into the creation and management of sessions. Before we do so, let's just look at the structure of our project again. There's a very important file in here called package.json. I haven't really talked too much about it so far, but this is a key file in the structure of the application we've been building. And you'll be getting to know this much more detail in later modules. But for the moment, let's just have a read through of it and see some of the interesting things. We've got things like the name, version, description. You can see those at the top. The main application, server.js, which is where our application kicks off. We see a script associated with starting the application. So if you've been choosing to run the application using Visual Studio Code, you've been effectively running this. We can put in, and these are optional, the GitHub repository where this project may be stored, some keywords, the version of Node we're using, and some code quality issues to do with formatting. The one I want to focus though on here is this one, the dependencies. These are the components we're using in building our app. Our app is a Node Express app. Node is the platform, comparable in some ways to the JVM, you may recall from Learning Play. And the framework we're using is Express, and this actually corresponds closely enough to the Play framework we were exploring earlier. If we're going to use these framework and other associated tools, we must declare them here in our dependencies, and this is what we're looking at now. Breaking it down a little bit further, the Express framework is composed of a number of modules. I'm listing them here. The database we're using is LowDB, and the tool we're using to generate user IDs is UUID. All those are listed here individually. Each of these is documented separately. So for instance, we can explore the Express framework here, going to the express.js.com. It outlines basic structure of what we've been doing to date, in fact, and there are quite a large range of tutorials and other material in Learning Express. This is a LowDB database package we've been using. Again, it's open source. It's reasonably lightweight, simple enough database. Remember, when we were learning Play, we would have been using a database associated with SQL, which we'll be exploring in more detail in the autumn. But here we have a simple file-based database that we're using. UUID is a standard, actually, used extensively in software development for generating globally unique IDs. Some fairly sophisticated tricks it's doing there to make sure they are reasonably solid uniqueness. And we've been using those whenever we've been creating objects in our database. We've been creating IDs for tracks, for playlists, and for users. Sessions now are supported by another module called Cookie Parser, which you can read about here. Cookies are not part of the framework, they're part of how browsers work, browsers and application servers. So the Cookie Parser component, if you like, is giving us a simplified interface to that system. So how do we do it? Well, in accounts register, we'll be registering our new user. We don't necessarily need to get into cookies there. But for authenticate, this is where we will be creating a cookie, and this cookie will hold the session for the current interaction. That is, allow us to know who is logged in and track that user across interactions with our application. Effectively, this means that our register will create a new user in our data store. Our authenticate will check the data store and create a session if a user is found. Here's our user store. It's going to be now managing users. We sometimes call this a CRUD sort of store, create, read, update, delete. Very common sets of procedures to do on information. And it's structured very similarly to the other stores we've built so far, the playlist and the track store. Get all users, add a user, get a user by ID, get a user by email, delete a user by ID, and delete all users. Again, as before, we're not too worried about how this actually works. Treat it as a black box that those methods we're invoking will interact with and deliver some simple results for us. Mostly it's implemented using array functions. We've discussed those earlier, but also we're using the library, LowDB. In particular, you'll notice the db read and db write. These are behind the scenes doing the updating onto our JSON file. So this is what a JSON store for users might look like. It's similar to some of the others, first name, last name, email, and ID. So it's just a collection, really, relatively simple. So for our sign up, we're going to do something very simple. The user has filled out the form. That form is packaged into the request body. And we just put that into a user object or get a hold of it in a user object and add that to our store. So it's quite simple and nothing too onerous going on here. No real validation, no real checking are all the fields filled out, you'll notice. We're just getting a very simple version of this up and running. For authenticate, we've got a bit more work to do. Specifically, we've got to interact with the cookie system. What we're doing here is we're checking to see if the user exists. If the user exists, we are going to create a cookie based on that user's email. And we're going to log that to the console. Again, we're not doing any checking here. We're not even doing fairly obvious checking, which would be, has the user entered the right password here? So I'll leave that for you to figure out how you might do that. Obviously, you'd recover the password the user indicated. And then if you had found the user's entry in our store, you would first check to see does the password match. So utility method then, recover from a request who the logged in user email is. This will return a valid user if a user exists. And we're going to recover the user object. This will include first name, last name, email, password, and ID. So we've got full amount of information here available to us. And this takes us back then to how do we use sessions. We call this method get logged in user, passing the request, and the login user will have an ID field, and we use that when we are retrieving information from the store. Similarly, when we're adding a playlist, again, we can find out who's logged in and use that ID when we're creating a new object. So the key here is when we're logging in to set the cookie. That is, we're setting the cookie here. Response.cookie, we're naming the cookie, and we're putting in the user's email as the cookie contents, as the string, if you like, of the cookie. Remember again, we're not checking password here. You should be doing that. So if all that comes together, we can actually see the cookies. We can see them in the browser. We go through this in the lab. We'll be able to see a list of all current cookies for this application and their values. Again, we would be probably a lot more careful with this in real life, perhaps considering ensuring it's encrypted, but we're keeping it fairly simple just to get up and running. Password check, as I mentioned, that would be important to do. And logging out would also be important. Once we've logged out, we want to clear the cookie. And again, we can check to see if this is working in the browser. If we press the logout button and we trigger the logout controller action, which in turn triggers this method here, then we should see the cookie being reset. So we're choosing to just put a blank in here, so the cookie will still exist, but it doesn't contain any values. So this is simple enough. It's not that difficult to take the current application we have and incorporate sessions. This makes it vastly more usable. We can support multiple users signing up. Whenever a user logs in, they will see only the playlists associated with that user's ID.